Hello everyone, welcome back to the channel. I hope you are doing well. Today I'm going to introduce the upflow anaerobic sludge blanket reactor, which is abbreviated as UASB. Why this system is important? We are looking at this system because it's one of the high rate anaerobic reactors that are characterized by having high concentration of sludge. And of course, this high concentration of sludge can be maintained inside the digester by physical retention, like maybe anaerobic filter, or maybe by immobilization of the sludge. So basically, we have today this UASB is one of the examples of immobilization of sludge. And of course, this also high rate anaerobic digesters or reactors are characterized by the fact that they have higher solid retention time, basically high biomass retention compared with liquid retention time, which means that the system would be having higher conversion rate. And in this case, we will have higher loading capacity. And of course, also these systems can be more efficient, of course, and more smaller, because basically if you have higher loading rate or higher loading capacity, this means that you have a smaller reactor to achieve the same conversion like conventional reactors. Relative capacity or relative loading capacity could reach something like 75 times, this should be times, sorry, that of the completely mixed reactor. So basically here, if this is something like, this is basically examples of higher rate digested reactors. The first one is physical retention, maybe like anaerobic filter, or maybe immobilization biomass, as our example today is UASB, or maybe something like enhanced contact, maybe something like anaerobic filter combined with recycling of biomass. This could also contribute to the higher efficiency of the conversion of the organic matter in the wastewater. Okay, so the upflow anaerobic sludge blanket bed. This is basically the system here was invented or developed basically in the Netherlands, invented by Professor Gatze Lettinga, and it contains granular sludge. This is basically the sludge here retains a higher active biomass with excellent settling capabilities in the reactor, and also this system has low sludge volume index, and we may actually have another video to explain what we mean by low sludge volume index. And of course, this systems can improve the separation of sludge from the effluent or from the treated wastewater. Of course, this systems has been applied efficiently to treat various high-strength industrial wastewater that characterized by high chemical oxygen demands, and also these systems also are used for high biodegradable wastewaters that are characterized mainly by high BOD to COD ratios. What are the main parts of the upflow anaerobic sludge bed? Sludge blanket, UASB. So basically we have, this is the body of the system can be shaped as cylindrical or rectangular shape. And here we have influent, of course. The water comes from the influent pipe and then pumped through a distributor that distribute water over or upflow. And here we have, this is the sludge bed. Here, the sludge blanket, basically. And this blanket, again, this is a granular sludge. And then the water actually get in contact with the granules, and some of the granules can maybe actually flotate through the liquid. And here, this is basically are converted to biogas. This is the small dots here. This is the yellow dots. This is biogas, and this is the gray ones. This is the granular sludge. And then as the water actually travel upflow, so basically some of these particles come together, and it can be separated through this kind of three-phase separators that separate the solids from water and gas. So basically the biogas can go up to the top of the reactor, and of course some of the also biogas some gas and some solids can be get in contact with these bubbles that actually also give more time for this particle to travel up. So basically this is also can give more residence time for these solids to be achieved. And then the particle again, which is the solids and the biomass, this go back to the blanket again. And here we have, this is basically the water that is treated, goes through this where actually controls the level of the water inside the digester, inside the reactor, and then goes to the effluent. So basically, again, this is upflow system, means that the inlet from the bottom and the effluent from the top. Okay. So what are the main features of this upflow reactors? The height to the diameter is almost in this range, 0.2 to 0.5, which means that you have maybe wider system. And then the velocity for the upflow velocity, it's ranging from 0.5 to 1 meter per hour. And of course, these systems, we may actually go back to design this system one day. And this, of course, again, these systems produce low amount of sludge, and then this sludge actually has improved characteristics for dewatability. And of course, about 5 to 10% of the organic matter in the wastewater is transferred to the sludge fraction. So basically, low actually sludge is produced in this system. Of course, this system significantly reduces energy expenses compared with other system. And even if you have low sludge production, this means that you will have less energy used for the aeration if you have this kind of secondary system to treat the sludge from the digester, from the reactor. I usually use digester and reactor as the same meaning in this case. This system is also very effective in degradation of high biodegradable substrate, especially the wastewater from food industry. And this the HRTs is less than 24 hours. And of course, the SRT, which is solid retention time, can be very long compared with the HRT. This is why actually, as I mentioned, this is what we call it high rate systems. The organic loading rate, of course, is higher than 20 kilogram COD per cubic meter per day, and we can obtain high removal efficiency, more than 90%. Okay. The factor affecting the performance of upflow anaerobic sludge blanket, many factors like conventional system, like temperature, like pH, like alkalinity, all of that should be also maintained here. However, this is just, I list some interesting actually factor besides this, besides the normal operational factors, but here I just listed the salinity. Salinity is very important parameter in the UASB. anaerobic treatment, especially for treating brackish streams. So the salinity affects the removal of substrate, the removal of COD, for example, can be achieved even at salinity under 10 gram sodium chloride per liter. Of course, lower salt concentration stimulates the formation of larger granules and faster degradation rate. So basically, you would need actually to think about this salinity as one of the factors affecting the performance of the reactor when you design it. Wastewater, of course, that has also high lipids can affect the performance. Especially, it can cause clogging, or maybe can also cause sludge flotation. Basically, if you have granular sludge, it can be float. And of course, it can also cause foaming and odor emissions and biomass wash out. Of course, if you have this also lipids, sorry, if you have lipids, it can also affect the activity of the sludge. And of course, at the end, it will be affecting the performance of the system. Here, this is the characteristic of methanogenic granules. This is just two examples. Here's the top example from potato wastewater, and the lower one from paper mill wastewater reactors. And the good quality granules characteristic, including the metabolic activity. So the specific methanogenic activity for good granular sludge ranging from 0.1 to 2 and 2 kilogram COD per kilogram VSS per day. And typically for industrial wastewater, this activity is ranging from 0.1 to 1 kilogram COD expressed as methane, of course, here kilogram VSS per day. And besides the metabolic activities, there are some kind of settlability and other physical properties. Also, these are important factors. The settling velocities may be ranging from 2 to 100 meters per hour, and typically from 15 to 50 meters per hour. The density of the granules may be 1 to 1.05 gram per liter, and the diameter of the granules 0.1 to 8 millimeter, and typically 0.15 to 4 millimeter. Of course, the shape should be spherical and well-defined shape. With maybe the color can be ranging from black, gray, or white. So you can actually read more about this in this chapter here. I cited it here, and also there is another also references that also I cite here. So you can actually go to these two references to learn more. With that, I would like to thank you, and I hope this is a useful video. And with that, if you would like to have any comment, yeah, please write it down and make sure you like and share this video with others. And see you next time. Thank you.